In our third lesson in our mini factoring unit, we will be looking at some special cases that we will be factoring with our binomials. What's nice about these examples being special means if we can find a pattern, there is actually a very quick, easy way to factor these binomials. So go ahead and write down today's objective. I will be able to factor special cases with binomials. Once you are done, let's go ahead and get started. First thing I would like you to just visually get an idea for is looking at a multiplication chart. There is a type of number called perfect squares. Numbers are called perfect squares because if you look at them, their dimensions or their area is a perfect square. If we were to look at 4 times 4, that would be something that measures 4 across and 4 down, and that makes a square. The answer is 16, so 16 is a perfect square. If I were to look at another example, let's say 7 times 7. If I were to look at those dimensions, that measures 7 across and 7 down. That is another square. The answer is 49. So I'm hoping you're noticing the numbers that I would love to jump out at you are the numbers that are in light blue right down the center. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, and 144. There are many more as long as you'd want to continue. However, we're just going to stop with the 12s. These are numbers you need to become familiar with, as if when you see them, you realize there's a pattern that we're going to follow and make our life easier. So knowing those numbers is going to help make our life easy. Here's how you know when you have a difference of squares. If you have a binomial, remember bi means 2, so 2 terms, and both terms are perfect squares, and they're being subtracted, then you have a difference of squares. This is a statement I would like to have written in your notes. We will look at an example in just a second. Here we go. Look at this first example right here, x squared minus 1. If we were to put that middle term, just like we did the other day in our notes, there is in fact no x's, so we could write it as 0x. This is a little extra work. We're only going to do the extra work for 3 times, and then we'll discover the pattern, and then we'll find our shortcut. Well, what two numbers multiply to negative 1, and those same two numbers must add to 0? Well, the only way to get there is 1 times negative 1, because 1 plus negative 1 is 0. So x plus 1 and x minus 1 are our factors. Let's look at the next one. We would have x squared. Fill in that missing term. There are 0 x's, minus 4. The two numbers that multiply to negative 4 and add to 0 are positive 2 and negative 2. Are you starting to catch on by any chance here? Let's look at one more and see how we're doing. X squared minus 9 means we have x squared plus no x's minus 9. Well, the two numbers that multiply to negative 9 that add to 0 are positive 3 and negative 3. Now, yes, you might be seeing a pattern of 1, 2, 3, but that is not the pattern that I want you to find. Can you look at the original problem, let's say x squared minus 9, and can you look at the answer and find a shortcut? Take a moment, because I'm not saying it just yet. See if that shortcut works with x squared minus 16. If we were to do the next one, does your pattern work? We know they both begin with an x. We would need a positive 4 and a minus 4. What was the pattern? What does 16 have in common with 4? Well, here's how you decide. 16 is a perfect square. So if you look at 16 on your multiplication chart, those factors are 4 and 4. All we do is make one positive and one negative. The other term that may have come to mind is the perfect square and square root. So here's what I want to show you if you have not caught on just yet. If we have two terms that are being subtracted and they are both perfect squares, what that means is the way you get each term is you square one term. So for example, the way we get x squared is we would do x times x. The way we get 49 is we do 7 times 7. Well, in order for it to add up to 0, because remember there's no x term right here in the middle, one has to be positive and one has to be negative. That's it. Let's look at the next one. The way we get to x squared is we do x times x. The way we get to 25 is we do 5 times 5. Well, the way it adds to 0 in the middle is one is positive and one is negative. Go ahead and finish with this pattern. Hopefully you are seeing that this would be x plus 6 and x minus 6. If we continue moving on, we should see this would be x plus 8 and x minus 8. And our final one would be x plus 9 and x minus 9. Now remember from the previous lesson, you could write those factors in either order. You could write x minus 9 times x plus 9. That is the same answer. The order in multiplication does not matter according to the transitive property of multiplication. Excuse me, the commutative property of multiplication. So order does not matter. So let's go ahead and practice factoring our special cases. This one's a little different, but it's still the same idea. The way we would get 4x squared, because 4 is a perfect square, it is 2 times 2. The way we get 4 is we multiply, like I just said, 2 times 2. The way we get the x squared is we do x times x. So the square root of 4x squared is 2x. Now look at your 9. That is a perfect square because 3 times 3 is 9. Now remember, there's 0 x's in the middle, so the only way this works is if one is positive and one is negative. So by you simply knowing some multiplication facts and seeing that we are subtracting two perfect square numbers, we can go right to the answer. If you did not see that, you would have to do this work. And then we would have to find a process that we don't even know yet because our leading coefficient's not just a 1, so we cannot just go right to the x. This is actually a very involved process. So we want to make sure that we are paying attention to our multiplication facts. 16 and 25 are in fact perfect squares. That means 4 times itself is 16 and x times itself is x squared. So both of our terms begin with 4x. Looking at your second term, the 25, that is a perfect square. 5 times 5 is 25. Well, in order for there to be no term in the middle, one has to be positive, one has to be negative. So what you have to recognize is if there's only two terms, they're being subtracted and they're perfect squares. Factoring is super, super easy. So let's take a moment, look at these three. See if you can write down the problems, factor them, and then unpause the video to check yourself. I should take a moment to pause just to make sure you are good at this part. We are going to find a GCF first. When you look at this first example, 4x squared minus 16, you need to realize 4 goes into both numbers. So I'm going to pull out the 4, divide it out, which leaves me with x squared minus 4. What I'm hoping you will see now is in parentheses that x squared minus 4 those are a difference of perfect squares. We would have x, and the square root of 4 is 2, so we'd have a positive 2 and a negative 2. So the difference here is we pulled a 4 out, then we factored the perfect squares. If we had not taken the 4 out, and we had just said the square root of 4 is 2, so that would be 2, and then the square root of x squared is x, and then the square root of 16 is 4, we'd have plus 4, and then 2x minus 4. One thing you need to know is this is similar, it's equivalent to the one we boxed in. However, do you see they share a GCF? 2 goes into all of these numbers. So we would want to pull a 2 out of the first one and a 2 out of the second one. Well, 2 times 2 is 4, and that's the 4 we pulled out to start. So what we need to realize is that if they share something in common, we need to pull it out first. So now let's look at our next one. There is no number that goes into 9 and 64, so there's nothing to pull out. We should get excited because 9 and 64 are perfect squares. That means I get to go right to my answer. The square root of 9 is 3, so it's 3x for both. The square root of 64 is 8, so I can go right to the 8 for both. Because there is no term in the middle, one must be positive and one must be negative. That's it. Let's take a moment and look at the next one. Both 16 and 100 are perfect squares, so let's go right to the answer. The square root of 16 is 4, so they both have a 4x. Square root of 100 is 10. One must be positive and one must be negative. Now here's something interesting. Do you see that a 2 can be divided out of the 4 and the 10, and a 2 can also come out of this 4 and 10? That means we should have pulled out a greatest common factor to begin with. It's kind of like reducing a fraction 4 over 8 and saying that it equals 2 over 4. That's true, but that's not the simplest you can reduce it. So let's look at this problem again. 4 can be divided out of both of these terms. So let's pull a 4 out. That would leave us with 4x squared minus 25. I'm simply reducing these fractions by dividing them by 4. So now, in parentheses, these are perfect squares again, so let's factor them. The square root of 4 is 2, so they both have a 2x. The square root of 25 is 5. And because there's no term in the middle, one must be positive and one must be negative. So the fully factored, the fully simplified answer is 4 times 2x plus 5 times 2x minus 5. So the question becomes, how do you know when to pull something out before you go to the shortcut? Well, if you go to the shortcut like we did right here, and you see that they can be reduced or there's a factor they share, then you know you should have pulled something out. Once you feel comfortable with those, let's go ahead and look at the next 3 examples. If you feel you can go ahead and solve them, I'm going to have you pause the video, come back when you are done, and check your answers. So how did you do on those 3? None of those 3 had a factor that they shared in common that you needed to pull out first. When you take the square root of each term, in the end, what's left in parentheses does not share a common factor, so nothing needed to be pulled out ahead of time. So take a moment. If you're not comfortable with that, take a moment, check and see what I've got, and make any changes you need. Once you feel comfortable with these last 3 examples, you are done with your notes and you are ready to move on.